In this problem, you're asked if 52 is divisible by 13. Now, they're not asking you to divide 52 by 13. What they're asking is it possible to divide 13 into 52 and get a whole number answer? So, how do I determine this? Well, I'm going to divide 52 by 13 and see if I get a whole number answer. And you can do this on your calculator. You get 4, comes out even. There's no remainder. So since the remainder is 0, or you can say there's no remainder, then the answer to this question is yes. So, oops, there we go. Yes, 52 is divisible by 13. Another way of writing this would be to say 13 divides 52. Now again, this means 13 divides 52. It does not mean 52 divided by 13. Okay. Now, next question is, does 7 divide 56? That's what's written there. So, I check, and you probably remember from your multiplication tables, 56 is equal to 7 times 8. So, is 56 a multiple of 7? Yes. The answer to that is yes. And moving on to the next one. Here we have, does 3 divide this expression? And what I do is I look at each individual factor and I say, is there anything in common that I can factor out here? And for the first one, it's a no. For the second one, no, there's no common factor. For the third one, yes, there is something I can factor, and it's a 3. So I can put the 3 out front, and I have 3k plus 1 times 3k plus 2, and then times a k plus 1 on the end there. Does 3 divide this? Yes, because 3 is one of the factors. So my answer is yes. So I'm just looking to see, is it possible to make this a factor? Now, what if I could have factored more from the binomial? I wouldn't have. I really just wanted to take out the 3 because I wanted to see if 3 divided. Okay. Is 29 a multiple of 3? Well, we know 27 is because 3 times 9 is 27, and then 3 times 10 is 30, so 29 is not a multiple of 3. And you could also divide it, just as we did before. 3 goes into 29 9 times, and there's a remainder of 2. And notice that I'm doing this the old school remainder way instead of saying 2/3, 9 2/3. So the reason for that is really going to come into play a little bit more in the next section. But do think that way. Think about remainders when you're doing this division. All right, how about number 7? Is -3 a factor of 66? Well, I know that 3 divides into 66 evenly, right? That's easy enough, and it goes in 22 times. So is -3 a factor of 66? Is there an integer? Doesn't have to be a positive integer. Is there any integer that I could multiply -3 times some integer and get 66 as an answer? Well, sure, I'd multiply it by a -22, and that would work. So is -3 a factor of 66? Absolutely. And let's take a look at 8. It says, is 6a times a plus b a multiple of 3a? So what I want to do is I want to rewrite this 6a times the quantity a plus b as 3a times something, if that's actually possible. If it's not possible, then I'll say, no, you can't do it. So we've got 6a times a plus b. Now, some people might go ahead and distribute and then try to factor out a 3a. You can do it that way. But really, all I have to do is look, does 3a divide into 6a? Yes, it does. So 6a is 3a times 2, and then I just don't lose the a plus b part. So I have 3a, which is my factor, my thing that I want to see, is it a multiple, or is 6a times a plus b a multiple of 3a? And then here's the leftover stuff. Okay, so again, my answer is yes. And one more from this group. Does 7 divide 34? And I try to take 7 into 34, and it goes 4 times with a remainder of 6. So it almost divides 34, but the answer is no.